Okay, so guys, welcome to today's Codeforces Div 4 post contest discussion. Today we'll be discussing problems A to G1. Unfortunately, the contest got unrated, but we can always learn from the problems, right? So let's get started. So guys, let's start. So we'll start from problem A, and yeah, the problem is minimize. You are given two integers a and b over all possible values of a smaller than equal to c smaller than equal to a and c greater smaller than equal to b. Find the minimum value of c minus a plus b minus c. Right? So guys, what does the problem say? Very quick. We are given two integers a and b for all numbers in the range a comma b. Let's say that number we chose is c, right? We need to calculate c minus a plus b minus c. All right. Now, over all the values of this, we need to find what gives the minimum value of this, right? Yes or no, guys? This is what the problem says. Put a yes in the chat if it does say this, right? Now, if it does say this, you don't need to do any brute force, anything like that. What do we need to find? We need to find C minus A plus B minus C. These are not absolute brackets, so you can just remove this. So it is C minus A plus B minus C. You will notice that this C and this C gets cancelled. The answer is just B minus. That is all. Is this clear, guys? A very simple mathematical problem. For each a comma b, you can answer it in O of 1, right? So you take in input a, b, right? And then you print b minus a. That is more or less it for the first problem. Let's move on to the second problem, right? So guys, what is the second problem? You are playing your favorite rhythm game, right? I don't know how to pronounce that, but yes. The layout of your beat map consists of n rows and 4 columns. Because nodes at bottom are closer, you will process from the bottommost row and the topmost row last. Each row will contain exactly one note represented as a hash. For every note from 1 to n, in the order of processing, output the column in which the note appears. If we look at this particular grid, you can see that in the last row, it appears in the fourth column. So we print 4. In the second last row, it appears in the third column. So we print 3. In the second column, it appears in 2. So we print 2 and then we print 1. So we have to process from the last row up to the first row, and wherever this hash occurs, we have to print its index. All right, guys. So this is also a very simple question. What does the question say? You are given a grid. All right. It will be of n rows and 4 columns. For every row, you need to iterate from the last row up to the first, and you have to print at which index it occurs in one based indexing. So for this particular grid, it is 4, 3, 2, 1, because this is index 4, this is index 3, this is index 2, this is index 1. All right. So first of all, since here it is 4, we could have taken input as a vector and just printed it. But there is a much simpler way to do this. So guys, in C++, if you pass a vector and you pass an element in the find function, all right. If you do find a dot begin, a dot end, comma x, where x is the element you want to search, this will return an iterator to where that particular element is, or it will return dot end. Now, from this particular value, if you subtract a dot begin, it will just give you the index of the element where it is present at. All right, this is a very simple trick that you can use. So I can, for every string here, I can just call the find function, and then in the find function, whatever index I get, I can just print that +1 because we are talking in one based indexing. Is this trick clear for everyone, guys? If you don't want to use the find function, you can just run a for loop and find the particular index. It is an O of n into m solution. Here m is fixed at 4. So it's an O of 4n or O of n solution. Is this clear for everyone? Yes or no, guys? Tell me.
Yes, sir.
Okay. So a very simple implementation problem. Let me just show you the code as well. I have n strings. So I take an input of n strings. And after this, what do? I iterate from n-1 to 0 because I want to find the index in the last, second last, so on and so forth. Then I just find the index of the hash. I know it is present and I know it is present only once. So find ai dot begin, ai dot end hash minus ai dot begin. This much will give me the index, and then I do a +1 because I want to print in one based indexing. Now in the end, when I 0, I want to print a endl or a new line. So that is why I'm using this another trick. So for all elements apart from the 0th element, it will print a space, and in the end, when I is equal to 0, it will print a \n. This is something that legendary grandmasters used to save time. Just if you want to use this, you can use this. Otherwise, you can print a space here, and in the end here, you can print a \n. Yes, exactly. This is what Jiangli used. So is this solution clear to everyone, guys? I'm just moving fast because these problems are just implementation problems. Now let's move on to problem C, the legend of Priya the frog. Priya the frog is traveling on 2D coordinate planes. She is currently at a point 0, 0 and wants to go to point x, y. Right now, what she can do in one move, she chooses an integer d, where d ranges from 0 to k and jumps d spots in the direction she is facing. Initially, she is facing in the positive x direction. After each move, she will be alternatingly facing the positive x direction and the positive y direction. All right. We want to find the minimum number of moves required to land on point x, y. So again, this is a very mathematical problem. It's more about formulating what we want and solving it. So guys, let's have a look what the problem says. We are given a grid. All right. We are on 0, 0. We want to reach point x, y. Okay. Now, in the first move, we go some steps forward in range 0 to d. All right. So this right here, or this right here, whatever you want to consider as the x-axis, it becomes, you can increase it by anything in range 0 to d. Now in the second move, you can increase the other coordinate by anything in range 0 to d. You keep doing these moves. In every odd move, you increase the x coordinate. In every even move, you can increase the y coordinate. You want to find the minimum number of moves. The minimum number of moves to reach x, y. Yes or no, guys? Tell me. Yes or no? All right. Now, let's solve for each case separately and let's have a look. So guys, from 0, 0, we want to reach x, y. All right. Do you agree that for this, in x direction, I will have to go X steps ahead. Yes or no? Yes. So do you agree that I will keep subtracting? Like if I only did operations on this X axis, let's forget Y axis for now. Let's say it was only X. So how many moves would it require if on each move I can go anywhere from 0 to D steps ahead? Right? Now, guys, if you don't know about this, this is very simple. Do you agree that till X is greater than equal to D, I will just do X minus equal to D. And after that, when X is smaller than D, then it is just 1. Yes or no, guys? Yes or no? Like, for example, consider X is equal to 5 and D is equal to 2. Since X is greater than equal to 5, I will make 5 to 3. Then I will make 3 to 1. And now since 1 is smaller than equal to D, I will just make this 0. It took me 1, 2, and 3 moves. If you notice clearly, this is just seal off. I'm using this mathematical notation instead of the seal operator. I want you all to learn today, all right? It's seal of X divided by D. Yes or no, guys? All right. Now I think this is given as K in the problem statement, but just assume the variable name is called D. Now, guys, the first learning of today, seal of A comma B, right? In integer division, if you want to convert it, there is a very well formula for this. It is A plus B minus 1, the whole divided by B, right? This is a very well known formula. If you didn't know this, just keep this in mind for now. Harsh says, what is the formula for floor? Since it is in floor division is same as integer division, you can just do this. All right. This is for floor and this is for seal. All right. Now, guys, if this much is clear, do you agree that if I want to make 0 to X, I would be requiring seal of X divided by D moves? Yes or no, guys? Tell me. Yes. Okay. Now, similarly, if I wanted to make 0 to Y, would I need Y divided by D moves? Yes or no, guys? Yes or no? All right. So we have taken care of each case individually. Now, how would I solve this? Okay. So, guys, there are some cases. Since we need to do this X move, Y move, X move, Y move continuously, right? Alternatively. Yes. So, do you agree that if I am doing X by D moves for the X axis, all right, let's say I'm doing 3 moves for the X axis, I have to do at least 2 moves for the Y axis. Yes or no, guys? Tell me. If I am doing 3 moves for X axis, I will either do 3 minus 1 move or I will do 3 plus 1 move. Okay. So we just consider the case on which move we are ending. All right. Now, similarly, guys, let's say we ended on Y. The last move we did was for Y axis. Now, guys, do you agree that if I am doing 3 operations on the Y axis, I have to do 3 moves on the X axis as well? Yes or no? Yes. So guys, now this is very simple. Do y'all agree that the number out of X and Y which is greater, all right, the one which is greater, we will be doing more moves for that? Yes or no? Like not necessarily, but let's say X is greater than Y, then the number of moves for reaching X will be greater than equal to number of moves for reaching Y. Yes or no, guys? Tell me. Yes. Now, similarly, if Y is greater than X, then the number of moves to reach Y would be greater than equal to the number of moves to reach X. Okay. Now, we need to just solve this. If X is greater than Y, all right, let's say we find the moves to reach X. What is that, guys? It is X plus D minus 1 divided by D. Now, what is the number of moves we would do for Y? Guys, do you all agree that the number of moves we would do for Y is maximum of Y plus D minus 1 divided by D, comma, X plus D minus 1 divided by D minus 1? Because if I am doing some number of X operations and I'm ending on X, then the minimum number of moves I have to do for Y is the number of moves I'm doing for X minus 1. So whatever is maximum of these two is the number of moves I will be doing for Y. Yes or no, guys? Tell me. Yes, if X is greater than Y. Clear, guys? Is this much making sense? Now, similarly, if Y is greater than X, then the number of moves, right? Moves of Y is just Y plus D minus 1 divided by D. Now, can you guys tell me what will be the number of moves for X? It will be what, guys? It will be max of what? Tell me. One will be X plus D minus 1 divided by D. And here, will it be minus 1 or will it be same? Tell me, guys, would it be Y plus D minus 1 divided by D? Would it be same? Yes, it would be indeed same, because when I am ending by doing Y moves, if I've done 3 Y moves, then I have to do at least 3 X moves. So it has to remain the same. So do you see that for X axis, this is the formula. If X is greater than Y, and if Y is greater than X, then this is the number of moves for X, number of moves for Y. Once we have this, we can just print number of moves of X plus moves of Y. All right. And I have their formulae defined here. Okay, guys, is this problem clear?
Can you actually like explain it briefly again?
What do you mean by that? What didn't you understand? Tell me.
Like I needed a brief about complete solution. I understood in parts.
So if X is greater than Y, do you agree that there is a chance that you might just end up the last move you would do is a X move? Yes or no?
Yeah. Yeah.
Now, if the last move we are doing X moves, and let's say we have done 3X moves, do you agree that we have to do at least 2 Y moves?
Yeah.
So when X is greater than Y, do you agree the number of moves I'm doing on X is greater than equal to the number of moves I'm doing on Y?
Yeah.
Yes. So the number of moves of x, what is it? It is just CL of x divided by k or x divided by d. Yes.
Yeah.
Okay. Now, do
Okay.
you agree that if this is the number of moves of x, the number of moves of y has to be minimum this, that is number of moves of x minus 1.
Hmm.
So that is why number of moves of y is maximum of the number of moves of x minus 1 and the number of moves required for y itself. All right.
Okay.
Now, similarly, if we are ending for y, let's say this is not there. Do you agree if I'm doing 2 moves for x, I have to do at least 2 moves, 2 moves for y, I have to do at least 2 moves for x?
Hmm.
Now, in that particular case, do you agree that if this is the number of moves of y, then the minimum number of moves required for x is at least this much? We won't have a minus 1 in that case.
Yeah. Yeah.
Yes. So number of moves for x is just number of moves required for x, comma, the number of moves for y. And now, since you have the total number of moves required for both, you can just add them. All right.
Yes.
So that is more or less it. If I show you the solution, it's just a one-line solution. Um, if x is greater than y, then you can just print x plus d minus 1 divided by d plus max of x plus d minus 1 divided by d whole minus 1. Else we would do y plus d minus 1 divided by d. Otherwise, if y is greater than equal to x, in that case, we would do y plus d minus 1 divided by d plus max of these two. It's just a O of 1 solution. All right. Very, very simple. Is this clear for everyone? Someone is asking me a doubt. Does that work? I will definitely look into it after the post contest discussion. All right.
Do you
Vishwaraj?
think it's
Yes, tell me.
easy for considering beginner experience?
So the only thing you needed to know here is the seal function. So if you weren't able to solve this problem, you would like more or less you want to focus a bit more on elementary math. So if like I don't, so you were able to observe this, right? That you need to do alternating moves.
Yeah.
Yes. Now the only thing now one more thing is that how many number of moves is required if this was not there. This is something that you need to consider. And the last thing you need to consider is that if it's ending at x, how many moves I need to do at least for y. If it's ending at y, how many minimum moves I need to do at least for x. It is not very simple, but yes, if you understand some uh, if you solve more problems on math, this will get relatively easier. Okay.
Thanks.
All right. So that is more or less it. This like 1,000 rated problem.
सर
Let's
आपके
move
पास
on to the next. Yes, tell me.
क्या हम इसमें ऐसा कर सकते हैं, हम एक मिनिमम पॉइंट ले लेंगे एक्स और वाई का, वहां तक पहुंचने का डिस्टेंस निकाल के वहां से फिर जो भी पॉइंट बचेगा एक्स और वाई वहां तक का निकाल के ऐड कर लें अगर।
Uh, you reach minimum of x comma y.
हाँ, और उसके बाद जो भी हमारा पॉइंट बचेगा लाइक एक्स या वाई जो भी बड़ा होगा वहां से उसका डायरेक्ट निकाल लेंगे पॉइंट, मतलब जो जितने मूव्स लगेंगे।
It's the same thing. Like what I explained is same because after reaching a minimum of x comma y comma minimum of x comma y, in one axis you would do 0 moves, and in the other axis you would do some moves, right?
हाँ बट सेकंड टेस्ट केस पे गलत आया इसका आंसर।
I will look into your solution. The idea remains the same. I think there is some edge case handling you need to do depending on either x is greater or y is greater.
ओके,
Yes, this needs to be handled. Okay.
इसके बाद देख लेंगे ना, मतलब एंड में।
Yes, yes, definitely.
ओके, थैंक यू।
Okay.
Sir.
So guys, now let's move on to problem D.
Sir.
I hope problem C is clear for everyone. Okay. So what is problem D? Satyam is given n distinct points on the 2D coordinate. All right. It is guaranteed that y is either 0 or 1 for all given points x1, xi, comma yi. How many different non-degenerate triangles can be formed using 3 different points as its vertices? Okay. So guys, this is a very interesting problem. For some reason, all problems today are very math heavy. I mean, it's not math heavy, but okay. When I tell you the solution, you are going to be very shocked. Okay. So guys, what does the problem say? You are given a 2D plane. Okay. And in this 2D plane, either y is equal to 1 or y is equal to 0. X can be anything. X can be smaller than equal to 10 raised to 9. Okay, guys? Is this much clear? And we need to find, let's say there is a point here, 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 there is a point here. And okay, these are the points. I need to find the number of right angle triangles I can make. The number of right angled triangles I can make. Okay, using these points. So is the problem statement clear to everyone, guys? This is a very interesting problem. So is the problem statement clear? Okay. So first thing that I want to ask you is that since y is equal to 0 and y is equal to 1, do you guys agree that one point would be on 1x? Okay, one point would be on 1y, all right, 1y, and the other 2 points would be on the other y. Yes or no, guys? Is this much clear? Otherwise, you can't make a triangle. Otherwise, what is the only choice? You have to select 3 points on the same y. Let's say y is equal to 0. Let's say your x is 1, x is 3, x is 4. It forms a straight line. It does not form a triangle. This is the basic case for a triangle, guys. What do I mean by this? If y is equal to 0 or y is equal to 1 here, you can consider them anyway. Let's say this is 0 and this is 1. So either 1 point is here and 2 points are here. So it becomes like this. Or 2 points are here and 1 points are here. And it can be in any direction. These are the sort of triangles I can make. Now I can also make a triangle which is like this. And this right here is 90 degrees. Okay. Is this much clear that at least this is the case that holds? 1 point is on one of the y axis, y numbers, and the other 2 are on the other y. Okay. Now, if this much is clear, guys, what are the type of right angle triangles I can make? First of all, let's analyze what kind of triangles I can make. First of all, I can make this kind of triangle, all right, where this x1 is fixed and then you have x2, and this is y is equal to 0, this is y is equal to 1, and this is a right angle triangle, all right. Similarly, you can have a mirror of this where y is equal to 1, y is equal to 0, this is x1, this is x1, and this is x2. Okay, guys, is this two types clear for everyone? Yes or no? Tell me this. Yes. Okay. This will form a right angle triangle. I hope this much is clear. Now, similarly, I can form its reverse. Okay. Here, this is 1, this is 0. You have x1 fixed, and this is x2. And similarly, in this particular case, you have 1, 0, you have x1 fixed, and you have x2. Okay, this much clear for everyone? Yes or no, guys? Tell me. Yes? All right, all right, all right. So now, are these the only 4 cases that are possible? The answer is no. Now, we could also have something like this, all right, where this is a right angle triangle. I have x1, I have x2, I have x3. Okay, and this is y is equal to 1, y is equal to 0. Similarly, oops. Okay, now this right here is y is equal to 1, y is equal to 0, x2, x3, and x1. All right. These are the 4 cases that are clear. These are the 6 cases that are possible. Now, guys, these 4 cases are easy. Okay, relatively easy. We need to find something special about these triangles. Otherwise, it will become really hard to solve them. Yes or no, guys? Tell me. These 4 types are very simple to think of. But what is special in these types, we need to know. Now, how will we come to know? All right, guys, the thing here is that since the difference between them is 1, okay, if this right here and this right here go in opposite directions and this needs to be 90 degrees, all right, then this is a fact, right? Let me just show it to y'all. Then if this particular is x1, this will be x1 plus 1 and this will be x1 minus 1. First of all, the thing to notice here is that you will be like, why so? All right. First of all, there is a test case in the examples that shows you that this is possible. All right. Even if you don't want to believe, this is possible. Now, exactly. So, guys, the thing to notice here, very, very simple, is that let's consider that this is a right angle triangle. Okay. And this here is, let's say, what can we do here? Okay. Let me just take this quick example that consider something like this. Let's say you have 5, let's say you have 7, let's say you have 3, and let's say you have 7. All right. You might be like, I assumed it might be for all midpoints, not for x minus 1, x plus 1, but let's say x minus 2, x plus 2. I'll tell you a basic fact. If x minus 1 and x plus 1 is giving you 90 degrees, do you agree that when I stretch this to x minus 2 and x plus 2, this right here would be greater than 90 degrees? Yes or no? Yes, angle will expand. So this and anything for x minus d where d is greater than equal to 2, it is not at all possible. Yes or no, guys? Tell me. Yes or no?
Yes. Yes.
And now another thing to notice. First of all, you might say that why I am assuming these two are same distance. Guys, I am assuming these two are on same distance because let's say this is the right angle triangle I want to form. If this length is y, this length is x, this length is greater. Do you agree if this is a 90-degree, they can't have the same y-axis coordinates if the lengths are not the same? Yes or no, guys? Or if I make this like this, all right, do you agree that the length here, like I've already proved that for x minus 1, x plus 1, it is a valid triangle. Now, if this is x plus y, this height is going to increase by 1. It is going to be greater than 1. Greater than 1. Yes? Yes or no, guys? Tell me. So, if I'm trying to increase this right here, then they won't have the same y axis. And if I'm trying to have both of them on the y-axis, they won't have the same height. Basically, this won't be 1 anymore. It would be more than this. Is this intuition clear to everyone? That why only this right here is the possible right angle triangle? Yes or no, guys? Someone has put up something. Mid of hypotenuse is equal to distance from each corner. Yes. All right. So is this clear, guys, that x minus 1 and x plus 1 is the only possible right angle triangle of this particular type? Yes or no? Tell me, guys. If it is clear, do let me know. If it is not clear, let me know that as well. Tapasya says yes. What about others? Come on, guys. We can have an interactive session. 30 odd people in the meeting right now. All right. So let me just recap for people who didn't understand, and then I will quickly take this ahead. So first thing, guys, for x minus 1, x plus 1, and x, it is possible. And this is 90 degrees. The first thing I want to point out is, if this was x minus 1, x minus 2, x plus 2, and this is x, do you agree that since we are increasing its length like this, all right, to form this triangle, this degree that we form would be greater than 90 degrees? Yes or no, guys? Yes? Okay. Now, what are the other conditions? The other conditions is that you made something like this, all right? And this is 90 degree, this is at y is equal to 0, and this is at y is equal to 1. Or this is y is equal to 1, this is y is equal to 0. Do you agree that if these two don't have the same length, we already saw that if these two lengths have to be same, then it is only possible for x minus 1, x plus 1. That is why it is not possible for x minus 2, x plus 2, so on and so forth. I hope this much is clear. If their lengths are same, then from x they will be equidistant. Now, if their lengths are not equidistant, if something is at y1 and something is over here, right? This point won't be at y is equal to 0. Do you see this, guys? If the lengths are not the same, let's say this is length 3, this is length 5, it's not possible. Yes or no? Yes? And you might say that why is it not possible? Then it can be something like this, that this is 3, this is 5, and this is 90 degree, and this is y is equal to 1, and this is y is equal to 0. You might be asking this. Now I'll give you another simple proof. For For consider this, all right. Very simple. This is 3, this is 4, this is 5. Now consider this length is 3, this length is also 3. Just consider for now. And this is 90 degree. We proved that this is a right angle triangle. Yes or no? Like we already know this is a right angle triangle. Do you agree that when I make its length 5, this won't be a 90 degree and won't be a 90 degree triangle anymore? Yes or no, guys? So now can you tell me that the only triangle possible is of type x1, x1 minus 1 and x1 plus 1? I just gave you a proof of why this is the only triangle which is possible. Okay? Is it now clear? Okay. Now, since this is clear, how do we count these triangles? That is all that I want to know. Okay. Now, counting these triangles is very simple. We can count for these triangles right here separately, and we can count for these triangles right here separately. Okay. Now, how can we do this? We don't need prefix sum or anything like that. I will just show you a very simple method to do this. Okay. So guys, let's say there is a point called 1, 0 and there is a point called 1, 1. Do you agree that I can have a straight line between them? Yes? Tell me guys. Yes, now. Consider that there are some more points here. All right. 2, 0, minus 1, 0, so on and so forth. Do you agree that no matter which point I choose on this axis, I can make a particular right angle triangle? Similarly, for anything that is over here, I can make a right angle triangle using this as well. Yes or no, guys? So basically, whenever I have two elements with the same x-axis, I can just increase my answer by n by 2, because how many points are there? If I have n points, I remove these 2 points, and apart from these 2 points, I can make a right angle triangle by fixing any point as the third point. Yes or no, guys? Tell me. Yes. So by doing this, by counting how many x-axes have both y is equal to 0 and y is equal to 1, I can increase my answer by n minus 2. So that will majoritarily sum up this. Yes or no? Basically, for a point x comma y, I need to check if x comma 1 minus y exists or not. If it exists, I will add n minus 2 to my answer. Okay? Yes or no, guys? Correct. Now, if this is clear, let's move on to how to count this triangle. Now, do you agree these triangles are more or less unique? Like from this point, I can make only this one triangle of this type. I cannot make more triangles of this type. So for a point x comma y, if it is the midpoint or this point or this point, I just need to check if x minus 1, 1 minus y and x plus 1, 1 minus y exist or not. Why am I doing 1 minus y? Because if it is 0, it will become 1. If it is 1, it will become 0. Yes or no? These are the only 3 points I need to check if they exist in my points. And if they do, I will do answer plus equal to 1, because I can make one such triangle. Yes or no, guys? Tell me. Yes or no? Is this much clear? Let me take this one more time. These are the only 6 triangles we can take. We want to count the number of triangles we can make using this, the number of triangles we can make using this. One common observation in this type is that your x-axis is fixed regardless. So what we can do, we can just count the number of triangles where x-axis is equal. Basically, for x comma y, x comma 1 minus y exists. If that is the case, I add n minus 2 to my answer for all possible, right? Now, similarly, if x minus 1 and 1 minus y exists, like for the other type, which is this right here, in this particular case, there is only one type of triangle for each x coordinate. If you look at these points, there is only one possible triangle. So for x comma y, I just need to check if x minus 1 comma 1 minus y and x plus 1 1 minus y exists or not. Yes or no? So if this is the case, you can just put plus 1 in my answer. Is this clear for everyone, guys? Mohit says how to prove. I just did that in some time. All right, Mohit, like I'll share the proof with you post the post-contest discussion. Okay. Is this clear for everyone, guys? Tell me. Yes. Now, if this much is clear, I implemented it in a bit of a more bad way, you can say, but I will just show you all. I have a pair and I have count 2. What does this store? It stores how many numbers have y is equal to 0 and how many numbers have y is equal to 1. Okay. Now, I am taking an input, I am storing it in a map, all right, and then I am setting count y plus plus. I could have also done it in a set since each points are unique. I don't know why I did that. Now I'm iterating over all points. Now, if for x comma y, x comma 1 minus y exists, all right, you can check in a map if something exists or not using dot count. If it exists, then I am saying that in this particular case, I can choose anything from that same axis. Do you agree that since we'll be iterating on x comma y in the map, I would be also iterating through x comma 1 minus y in the map? Yes or no, guys? What I'm trying to say here is that, let's say the points are 1 comma 0, 1 comma 1, and 2 comma 1, and let's say 5 comma 1. Do you agree that since I'm iterating on these points, if I iterate on 1 comma 0, I would be also iterating on 1 comma 1. So when I'm iterating on 1 comma 0, I am counting all the triangles I can make by using this axis as my third point. And when I'm iterating through 1 comma 1, I'm counting how many triangles I can make using this axis as my third point. I'm just trying to avoid over counting this way. I hope this is clear. More or less, n minus 2 only gets added. Some will be added here and some will be added here. Overall, n minus 2 get added. Okay, guys? If you implement the way that I suggested, it works. So that is what I am doing. And apart from that, for the other type of triangle, if it is x minus y, I just check if x plus 1, 1 minus y, and x minus 1, 1 minus y exist. If they exist, I am doing answer plus plus. In the end, I am just printing out answer. Right? This is an O of n log n solution because I'm using a map. You could maybe use something else, like you can sort them or something, and you can do it maybe simple. Okay. Someone asked what is the rating of this question. Okay, so I am not sure with that, but let's say around 1200, 1100, yes, around that. Okay. So is this solution clear to everyone, guys? We have only 6 type of triangles and we have to count all of them. Okay. My proof was a little bit here and there, but I hope you guys were able to understand. If you guys are able to understand that, let's move on with the next problem, which is problem. CLE has an array A n consisting of integers k1, k plus 1, k plus n minus 1 in this order. CLE wanted to choose an index I such that A1 plus A2 up till some particular AI. After that, minus AI plus 1, so on and so forth is minimized. Note that for an arbitrary integer z, z represents the absolute value. We need to find the minimum possible value of x. Okay. So guys, what does the problem say? The problem says that you are given an array. And in the array, you have elements of this sort. You have elements like k, k plus 1, so on and so forth up till k plus n minus 1. Okay. Now, what is our task? We need to find an index I such that AI plus A1 plus A2 up till AI minus AI plus 1 minus AI plus 2, so on and so forth up to AN. This absolute difference is minimized. Yes or no, guys? Now, isn't this? Yes. So, guys, this is actually very simple. How do you go about solving this question? Okay. The first thing to notice here is, guys, that this A1 plus A2 up till AI, right, minus AI plus 1 up to minus AN, this can be written down as A1 plus A2, so on and so forth up till AI minus AI plus 1 plus AI plus 2 up till AN. Do you agree when I open this bracket, this minus sign goes everywhere? Yes or no? Tell me, guys. Okay. Now, since this is clear and we have these two things right now, do you agree that these two terms should be as close as possible, right? So that the formula that is asked, so that the function which we are asked is minimized. Yes or no? Tell me, guys. Okay. Now, if this much is clear, the problem is more or less solved if you know one thing, and let me show you what. Guys, now tell me, if I randomly chose an integer I, okay, I know the sum from here till here, and let's say I know the sum from here to here, okay. I will tell you all how I can come up with the sum, but let's assume if I know the sum from of elements from 1 to I and the rest of the sum, then do you guys agree that let's say this sum is x, this sum is y. If x is greater than equal to y, then the sum is x minus y. Otherwise, if y is greater than x, then the sum is y minus x. Yes or no? Yes or no, guys? Tell me. If x is greater than equal to y, then the difference is x minus y. Otherwise, it is y minus. Okay. Now, let's consider this first case. Okay, where x is greater than equal to y. Okay. Do you see that this sum is greater than this sum? Yes or no in the first case? So do you agree if I want to minimize this even more, I will take this left so that this sum decreases and this sum increases? Yes or no? If I take my eye towards the left, then my x sum will decrease and y sum will increase. Okay. Now let's consider this case, all right, where x is smaller than y. Then do you agree in this case, I want y to decrease and x to increase. So in that case, I will move my I towards the right. Yes or no? Tell me, guys. So what I'm saying is, if x is greater than y, I can more or less discard this particular search space. And if y is greater than x, then I can discard this particular search space. Yes or no, guys? And now tell me, if x is equal to y, what do I discard? Tell me. If x is equal to y, what do I discard? Do I go to left or do I go to right? How do I know? Exactly. So in this case, I will break because my answer is 0 and I can't minimize my answer further. Yes or no, guys? That was a trick question. So now if you notice this, do you agree that we can just binary search for this particular index? Yes or no? Where on each move, we want to minimize our answer. If x is greater than y, then I go towards the left. Otherwise, I go towards the right. This much clear for everyone? Tell me, guys.
Excuse me,
Now,
sir.
yes.
Can you please explain this intuition once again? This when x is greater than y, all these things.
If x is greater than y, this sum is greater than this sum, right? Now we want them to be as close as possible, yes or no? So I would like to move my subarray a little bit less here, and I would like to increase this, yes or no, so that x becomes as close as y. Because I want to decrease x's sum and increase y's sum.
Yes.
Yes. So do you agree? In that case, I would be going towards the left. I would move my I pointer towards the left.
Yes, sir. Yes.
And in the other case, I would move my I pointer towards the right. Yes.
Yes, sir. Thanks for that.
Okay. So we can do binary search over this. Now, the only thing we need to calculate, do you agree? We need to somehow find a way to calculate the sum in a range. Yes or no? So guys, if I have my mid, and mid is not the index, mid is, let's say, the value. All right. Then I want to calculate the sum from k to mid. All right. And I want to calculate the sum from mid plus 1 to k plus n minus 1. Yes or no? Tell me, guys. Yes or no? These are the two things I want to calculate. Okay. Now, how do I do this? Very, very simple. Keep this in mind if you don't know this. Let's say there are some numbers from 1 to n. All right. 1, 2, 3, 4, 5, so on and so forth. And I want to know the sum of elements in the range L to R. Okay. Not the indices L to R, the numbers L to R. Let's say I want to know the sum between 5 to 7. Okay. How do I do this? I use prefix sum technique. Okay. Basically, what prefix sum is based on, what do I do? Tell me, guys, what is the sum from 1 to R? Sum of elements from 1 to R. R into R plus 1 by 2. Exactly. Now, do you agree? I only want to count from 1 to L. So I can more or less subtract the sum of values from 1 to L minus 1. If I do this, I would have this particular sum. Yes or no? Tell me, guys, if I know the sum from 1 to R, and if I subtract the sum from 1 to L minus 1, I would have this sum. So the only thing I need to subtract here is L into L minus 1 divided by 2, because I want sum till L minus 1. L minus 1 plus 1 is L. So do you agree that the sum of numbers in range L to R is R into R plus 1 by 2 minus L into L minus 1 by 2? Is this much clear for every single one? Tell me, guys. Yes or no? Okay. Harsh says, can you repeat this again? Definitely. So, Harsh, look at this. All right. If you can unmute, that would be amazing. Let's say I want to calculate the sum from 5 to 7. Okay. Let's say I calculated 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. All right. Which is the sum from 1 to R. Okay. What is this sum? This is R into R plus 1 divided by 2. Yes or no? Now, I only want 5 plus 6 plus 7. Yes or no? Tell me, Harsh. So I want to subtract the sum of these elements. What is the sum of these elements? Isn't it L minus 1 into L divided by 2? Because it is 4. So 4 into 4 plus 1 divided by 2. This is L minus 1 into L divided by 2. So R into R plus 1 divided by 2 minus L into L minus 1 divided by 2, it will give me the sum in this range. Now is it clear, guys? Tell me. Yes? Is this clear for everyone? Okay. Now, if this clear, we can just binary search over this. Let me show you the solution. So the solution is very, very simple. I have written a get sum, which given L to R returns me the sum in the range L to R. Okay. Now, my left is K, my right is K plus N minus 1. And initially, my answer is set as long max. While left is smaller than right, I have my mid as left plus right by 2. My sum 1 is get sum from K to mid, and my sum 2 is get sum from mid plus 1 to K plus N minus 1. Now, my final answer is minimum of answer, comma, absolute of sum 1 minus sum 2. Now, if sum 1 is greater than sum 2, then in this case, we want to go left. So that is why I set right as mid minus 1. Otherwise, I set left as mid plus 1. And in the end, I just print my answer. This is a very simple 5 to 10 lines of code. Can be solved in big O of n. Is this clear, guys? Tell me. This is what we call a lambda function. You could have written this here as well. If you don't know what lambda functions are, you can read upon it. It's basically writing functions inside your main function.
Excuse
Okay.
me, sir. Sir, like, what is the predicate function in this binary search case?
So the thing is, we have, like, it's not a predicate, like it's not 0, 0, 0 and then it is 1. Not that sort of function. But for a particular I, this is the most optimal, yes or no?
Yes.
For any other, let's say, if this I is my most optimal, if you look at I plus 1, I know, and for I plus 2 and anything else after this, I know that I need to go left to find my most optimal answer. And similarly for I minus 1, I minus 2, I minus 1, I know for these cases that I need to go right to find my most optimal answer. And hence, because I know which direction I need to go, and here I don't need to do anything, I can just binary search over it. All right. It's not something like it is 0, 0, 0 till here and then it is 1. It is not like that. All right. It's kind of like this.
So in general, sir, how to differentiate between these two types of questions?
You do not need to differentiate between, like here it is not obvious that you need to binary search. I will give you that. But if you look at what the function that you need to minimize, right? The direction is clear. Like, don't think of binary search as an algorithm, like where you need to have a predicate function and then only you can do this. You just need to prove that on any given instance, you are clear whether you need to go left or you need to go right. If you have this much data for every point, you can binary search over it. Okay. Like you can see for a particular prefix, my answer is only going right. And for a particular prefix, it is only going left. So maybe you can consider that as your predicate function. Like you can consider going left as ones and you can consider going rights as zeros if you want to formulate it as a predicate function. Okay.
Okay.
So it is 0, 0, 0, 0 up to a point and then it becomes 1.
Fine, thank you.
Right? Yes. So you can consider it like that. Now, guys, if this much is this clear for everyone? Yes or no? Tell me. If this much is clear, we'll go on to the next problem. Yes? Okay. So, this problem, Firefly queries. Firefly's queries. Okay. Firefly is given an array of n. Let Ci denote the ith cyclic shift of A. She needs to create a new array B such that B is equal to C1 plus C2 plus Cn, so on and so forth. Then she asks you Q queries. What is the sum of the subarray between B of L to B of R? Okay. This is a very interesting problem. And I think you'll get to learn a lot from this. So guys, initially I have my array A. All right. Consider it to be 1, 2, 3, 4, 5, 6. All right. Now A is same as A1 because it starts from the first element. Then you have the second element, third element, fourth element, fifth element, and sixth element. All right, guys. Now, what does the question say? Before that, what is A2? A2 is you start from the second element, then third element, then fourth element, then fifth element. Now, similarly, what is A3? A3 is 3, 4, 5, 6, 1, 2. So basically start from that particular element. Is this much clear? What a cyclic shift of I means? A of I means it starts from the ith element and then all the elements before it are basically pushed back at the end of the array. So from all A1 to AN, is the definition clear for everyone? Tell me guys, put a yes in the chat if the definition is indeed clear. Okay. Oops. So if the definition is indeed clear, what would we be doing? So guys, now we are going to have an array B in which I'm going to have first all elements of A1, then I'm going to have all elements of A2, then I'm going to have all elements of A3 and so on and so forth. Okay. Now, if this much is clear for everyone, we are given some queries now. All right. Q queries. Okay. Now, given a query, I need to find the sum of elements in this range. All right. Is this much clear for every single one of y'all out there? Tell me. Okay. Now, if this much is clear for everyone, how do we solve this? The first thing to notice is that if I'm given an L2R, let's say this is A1, this is A2, this is A3, this is A4. We can't use prefix sum here because each of these arrays is of size around 10 raised to 5. So the overall size of the array is 10 raised to 10. We cannot actually create this array. All right. It's not possible to create it and then use prefix sums. It's not. It'll give you a TLE. Now, what is the first thing you can notice here, guys, is that let's say I want this range, the sum of this range, or let's say the sum in this range, or let's say the sum in this range. Do you agree that these ranges can cover at most two of them incompletely? If you look at this range, it covers this incompletely, it covers this incompletely, and apart from that, all others are taken completely. Yes or no? And do you agree, regardless of what permutation I have of the array, if this sum is x, this sum will also be x of the entire array? Yes. So the problem basically boils down to, if I'm given a range L2R, I basically need to find which is the first kind of range it is partially covering. What is the last case it is partially covering? If this is AI and this is AJ, do you agree that J minus I minus 1, this is 0, this is 1, this is 2, this is 3. So 3 minus 0 minus 1, which is 2, it is covering two arrays completely. Yes or no, guys? Tell me.
Excuse me, sir.
Yes.
Sir, can you please repeat the last observation you made in the previous slide?
Yes. So basically what I'm trying to say is, if you consider this particular range, for example, consider this is A1, this is A2, this is A3, this is A4. And let's say I have this range. Okay. Do you agree that it will partially cover A1, it will partially cover A4, and it will completely cover all the other arrays?
Yes, sir.
So at most it can have two incomplete arrays with it, and everything else will be fully covered.
Yes, sir. Done.
Okay. So if this is AI, if this is AJ, and if I'm able to find them out, some suffix of AI, all right, some suffix of AI would be included, some prefix of AJ would be included. And apart from that, there are J minus I minus 1 arrays that are completely included. Yes or no? Tell me, guys. Is this clear for everyone? So if this is clear for every single one, then let me ask you all that for this J minus I minus 1, all right, J minus I minus 1, do you agree I can just multiply the sum of the array, sum of array? Yes or no, guys?
Yes, sir.
Right. Now, with that, this part gets clear. We only need to find this here and this here. Okay. Now, how do you find this? There is a very simple trick to this. Now, let's say our original array is 1, 2, 3, 4, 5. And currently our array is 3, 4, 5, 1, 2. So do you agree that this is the A1 and this is A3? Yes or no? Tell me, guys. Okay. Now, if in A3, I want to find sum between 1 to 2, What is it equivalent of finding sum in? It is finding 3 to 4. Yes or no, guys? Tell me. If I want to find sum of elements in 1 to 2, it's equivalent to finding sum in range 3 to 4. Now, if I am able to solve, if I'm able to convert this to this, do you agree that I can just find the answer using prefix sum for any AK? Yes. Like if I'm able to find for A4, A5, like if I find the relation of how it relates to the original array, I can just use prefix sums and solve this. All right. Now, the thing to notice here is that what is 3 minus 1? It is 2. Do you agree that this range has been shifted 2 steps ahead? Like it has been pushed. If this is 1, 2, this is 3, 4. You see that there has been a 2 when we do this. Yes or no, guys? Tell me. Now, this is basically the only observation you need to know. But there might be several questions in your mind. You might be like, if the original array is 1, 2, 3, 4, 5, and this is 3, 4, 5, 1, 2. Then in that particular case, let's say I wanted to find sum in this range, which is this is A3, this is A1, this is 2 to 4. So if I do plus 2, and plus 2, this becomes 4 to 6. Yes or no, guys? Tell me. This is 4, this is 5, but I don't have this 6th element. So what do I say? You can just repeat this array one more time, and now you do have the 6th element. Yes or no? Tell me. So what I'm trying to tell you, if in this array, you know which indices you want to know the sum in, what you could basically do is, you can find the LNR here, and then if you come to know which index number it is, let's say it's 3. So you can just do 3 minus 1 here, and you can just do 3 minus 1 here. You will find the range in which you need the sum in the original array. And for the original array, you can maintain a prefix sum. Yes or no? Tell me, guys. Clear? Is this clear for everyone? Okay. Now, if this much is clear, let me share with you how you can solve it now for entirety. I am given two indices, L and R. Let's say the array is of my A is of size 3. So this is the first element, this second, and so on and so forth. We are given in one based indexing, L and R. Let me convert this to zero based indexing. So do you agree this will be 0, 1, 2, 3, 4, 5, 6, so on and so forth? Yes or no? This is array 1, or this is array 0, this is array 1, this is array 2. I'm converting everything to zero based index. So if I want to know, let's say I'm given L is equal to 4. I want to know it belongs to array 1 or array 2 if you're talking in one based indexing. If you give me 1, I want to tell you it belongs to array 0. How do I tell this? Do you agree? This is just L divided by N. For 0, 1, 2, 0 divided by N is 0, 0 divided by 3, 0, 1 divided by 3, 0, 2 divided by 3 is 0. But now, if you look at 3, 4, 5, 3 divided by 3 is 1, 4 divided by 3 is 1, 5 divided by 3 is 1. So basically, once you convert in zero-based indexing, let's say L, you convert it to zero-based indexing, L minus 1. If you take L minus 1 divided by N, it will give you which array it belongs to. All right? Yes or no, guys? Yes or no? Yes. Now, basically, what do I want to do? Similarly, I can do this for R, yes or no? For R also, I can find R minus 1 divided by N. Okay. Yes or no? Tell me, guys. Okay. Now, if this much is clear for every single one of you out there, now there are only few things that I want to do, right? The first thing that I want to do is that um, for my L, let's consider this is the range and this is L. I want the sum in this suffix, right? And if this is R, I want the sum in this prefix. Yes or no? And I came to know which arrays they belong to. And I told you that if I know the indices, I can come to know the sum. If I know which indices or basically which L2R want to know the sum and which array it is. Let's say it is A5 or A7. If I know these three numbers, I can find the sum easily by making prefix sum over A1 or A0. Yes or no, guys? Yes? Okay. Now, for this suffix, I want to know the sum. But do you agree? I want to know for this L, what is the index of that array? Like, what is that? What is this index in ARRI? Yes or no? For example, if the array size is 3 and this is 0, 1, 2, 3, 4, 5. If I take 4, it is basically index 1 in my ARR of 1 or ARR of 2 if you're talking in 1-based indexing. So I need to find this index 1, right? Only then I will find the sum in range 1 to 2. Yes or no? Yes or no, guys? Tell me. Yes? Exactly. So what ranges, what indices do all of these array indices signify to? Let me just put my laptop to charging very quickly. Very simple. This signifies index 0, this 1, this 2. This remains as it is for array 1. This signifies 1, this signifies 0, this signifies 1, this signifies 2. And similarly, index 6 will signify 0 for ARR 2. Yes or no? So basically, if I know this index, which is L minus 1, this is basically just L minus 1 mod n. And similarly for R also, it would be R minus 1 mod n. Yes or no, guys? Tell me. Okay. So I have told you all parts individually. I'm just going to sum it up very quickly. I am given an L and R. This is my L, this is my R. Now I found out which index this is, which array index this is, which array index this is, right? This is ARR of I, this is ARR of J. It's that cyclic shift. Now I want to know the sum in this prefix. I want to know the sum in this prefix. By doing L minus 1 mod n, I found out this index. So from this index, let's say this is K to n minus 1. Let's say this index is L. So from 0 to L here. This can be done very easily using prefix sums. I explained this. Now, how many elements are there in between? There are j minus I minus 1 elements in between. So I can just multiply this by sum and I can know this sum and this sum in big O of 1 using prefix sums. So in general, I can just add this sum. Let's say this sum is x, this sum is y. I can just say my total sum is j minus I minus 1 into total sum of array into x plus y. Is this clear for everyone? I will show you all the code right now. So if this is clear for everyone, let me show you all the code. My code is very ugly, but I will brief you through this very quickly. All right. So I know which shift it is, like how much it is shifted. I'm calculating in zero based. So basically it remains as it is, because let's say it's A of 3, it's in zero based indexing, it's A of 2. And how much do I add? I need to add 3 minus 1, which is basically 2. So if I'm calculating in zero based indexing, it remains as it is. So for a prefix, if I want to know the sum of the array, it is basically from 0 plus shift modulo n to index plus shift modulo n. Yes or no, guys? This is the range I want to calculate the sum in. Yes or no? Yes? Okay. Now, I'm doing plus plus because I'm converting it back to one based indexing. I'm calculating my prefix sum in one base to avoid the zero case. Let's say I want to calculate 0 to r something in my prefix sum. I would have to handle that case separately, right? If it is 0, then you don't do range first minus 1 or so on and so forth. In my implementation, I did not take the array twice, but if you take the array twice, you don't need to do all of this, right? You could just take the array twice and do the trick that I told you. What am I doing? I did if range dot second, if the left is smaller than equal to right, okay, I can say that it is prefix of range dot second minus prefix of range dot first minus 1. Yes or no? But otherwise, if it is not the case, do you agree that if this is my array and this much I want to find, so there are some elements in my suffix and then some elements in my prefix which I want the sum of? Yes or no, guys? Tell me. Yes. So what do I want to do? And I know this index and I know this index because I found it over here. Okay. Basically, if range dot first is greater than range dot second. If that is the case, I want all the elements in my prefix. Since this is my R, do you agree? I want all elements in 0, 1, so on and so forth up to R. I want this entire range. And if this is L, I want the sum from L to N minus 1. So this is basically sum from 0 to R plus sum of L to N minus 1. Yes or no, guys? Tell me. Yes. So that is all that I'm doing. Sum from 0 to R and sum from N minus 1 to L, or N to L minus 1, N to L, depending upon which base index. Now, if you can do this for a prefix, you can similarly do this for a suffix. All right. I think all of this is not required actually. If I only had this function, which given an left, right, and shift, it calculates this. I think only this function is sufficient. Because I was in a hurry during the function in the contest, I just wrote this 3 times. But more or less, if I'm given left, if I'm given right, then it's just left plus shift modulo n, right plus shift modulo n, and these 2 cases. Okay. Is this clear for everyone? And prefix and suffix are just special cases of this. Clear? Yes or no, guys? Tell me. Yes. Okay. So I'm given L and R. All right. My first array, the index is L minus 1 divided by N. My second array is right minus 1 divided by N. All right. Now, if first array is equal to last array, do you agree last array minus first array minus 1 will give minus 1? Because this is equal to this, so it will give me 0 and this will give me minus 1. Yes or no, guys? Tell me. Yes. So I don't want that. So when left is equal to, when the first array is equal to the last array, I just call the calc range function in L minus 1 modulo n and R minus 1 modulo n. You might be wondering why have I not put modulo n over here? Because it works over here. I put modulo n over here, right? So calc range is just first array L minus 1 to R minus 1. But if they are not the same, then it is just the number of ranges in between into the sum of the entire array plus calculating suffix of first array from L minus 1 to N minus 1 and calculating the prefix of the last array from 0 to R minus 1. This is all that I am doing, and I am printing out the sum over here. and all these functions I have written here. So a general coding tip, if you want to code such problems, first you go writing this. If you know what you want to implement, you just call these functions, and after that you can start writing this function, that what exactly you want this function to do. This will help you think better instead of writing this function first and then figuring out where you should call it. Okay, guys? So first have an idea of what you need to do and higher overview. Then just write this first, and then you can write all of this one by one. All right. So that is all about problem F. Do you see that it was a bit complicated, but there is no DP or graphs or anything working here. What is the expected rating of this question? I don't know. It might be around 1600, around that rating. All right. Shouldn't be very hard, but yes. Okay. How many problems solved? How many people solved it? Let's have a look. So around 1800 people solved it. So around 1700 maybe. Okay. You see that it is not that hard when you think about it, but yes, some things need to be managed. So is this problem clear for everyone, guys? Tell me, yes or no? We solved it using prefix sums. The only observation we required is that in between, there are some things that are not there. Now, moving on to the last problem that we would be discussing today. And that is the easy version, that is G1. G2 and G3 were very hard today. So won't be looking at that. Maybe can refer to the editorial. But for this problem, okay, what is this? In this version, it is guaranteed that R is equal to L plus K minus 1. For an arbitrary B, Junli can perform the following operation any number of times. Select an index I. Bi, set Bi is equal to X, where X is an integer she desires, not limited between 1 to n. Now let's denote FB as the minimum number of operations to make the array consecutive. All right. So you are given a range and you need to find the minimum number of operations need to make this array consecutive. Now, what does making an array consecutive mean, guys? That the array should be of the form x, x plus 1, x plus 2, x plus 3, so on and so forth. Yes or no? Tell me. Is this much clear? So we are given an array of size n and we are given queries. Okay. And for each query, I want to basically tell what are the minimum number of operations to make that subarray of this type. Clear, guys? And on each operation, we can change any element to anything else. Is this much clear? Tell me. Put a yes in the chat if this much is clear, if the problem statement is clear. Okay? Yes or no? All right. So now, since this is an easy version, there should be something that is easy, right? So what is easy about this? That the size in which we are going to query is fixed as k. All right. What I mean to say is that for every L, the R is fixed and it is L plus K minus 1. For example, let's say the array is of size 5. So 1, 2, 3, 4, 5. And K is 3. So the only queries that can happen is 1 to 3, 2 to 4, and 3 to 5. Is this much clear for everyone? Yes or no, guys? Tell me. Is this much clear? All right. If this much is clear, this is size K, this is also size K, this is also size K, right? This much should already give you an hint on what the problem is about. Do you agree that this is a fixed size range and we are sliding it? Yes or no? So this problem is basically a sliding window problem. All right. Because if I am able to find the answer for these ranges and I keep them pre-computed somewhere, whenever I get a query, I can just answer whatever the answer was in that range. Okay. So this is a sliding window problem. Now, the only thing that we need to think here is how do we maintain the answer for a particular sliding window? So guys, in my array, let's say it is 2, 5, 4, and 5. Do you agree that if I change this 5 to a 3, then my array will become continuous? So the number of operations required is 1. Yes or no, guys? Yes or no? Okay. So now these elements, okay, 2, 4, and 5, we can say these are same type of elements because in my array, I can have these elements together and it is a valid array. I only need to put a 3 here. So these are similarly the same type of array. If I'm keeping this, then I can just keep these as well. It doesn't matter. Yes or no, guys? Tell me. Put a yes in the chat if it is indeed clear, guys. Okay. Now, if this much is clear, I just need a way to maintain that these elements are of the same type. And there is a very simple trick to do this. All right. This is 2, 3, 4, and 5. Okay. This is index 1, 2, 3, and 4. If this is 2, this had to be 3. All right. So something about these elements is same. And what is that, guys? For all these elements, do you agree as I'm going one step ahead, my index increases by 1 and then x also increases by 1? If this is index I and this is x, then for I plus 1, this is x plus 1. For I plus 2, it is x plus 2. All right. So if this observation is clear, do you see that for all elements, element of I minus I is more or less constant? This is 2 minus 1, this is 1. This is 4 minus 3, it is 1. This is 5 minus 4, this is 1. So all elements with the same element I minus I are of the same type. This is the main observation required to solve this problem. Okay. So if instead of having these elements itself, let's say 2, 3, 4, 5, and this is index 1, 2, 3, 4. All right. I can just convert this to elements of I minus I. So 2 minus 1 is 1. Let this be 5. All right. 5 minus 2 is 3. This is 1 and this is 1. And if I wanted to query in this particular range, do you agree? And let's say there was another 5 here, and for 5, this is 7. So this is of type 2 because 7 minus 5 is 2. So you can see that these two are also not of the same type. So guys, do you see that for this range, it is most optimal that I keep elements of the same type which have the maximum frequency? You can see that type 1 has frequency 3, type 2 has frequency 1, and type 3 has frequency 1. So if I keep all type 1 elements and change everything else, then I need just 5 minus 3 moves, which is 2. So initially, so what is my final subproblem? My final subproblem here is that for every sliding window, all right, of size k, I want to know what is the maximum frequency in that window. Okay, because if I have converted my array to something like this, in every sliding window, I want to know what is the frequency in that window. Now, this right here can be very easily done. This is a very standard trick I think this might be some sort of lead code problem or something like that. This is very, very standard. Don't know how to do this. Just have a look. This can be easily done using multiset and a map. All right. Now, let's say there is another. I'll just give you an idea how to do this. Let's say the range you have right now is 1, 2, 3, 3. So the frequency of 3 is 2, frequency of 2 is 1, and frequency of 1 is 1. Now, let's say you wanted to add another 1. Do you agree that this 1 frequency is increasing by 2? All right. But I can store these frequencies in a map, but I want to know what is the max frequency. So to store the max frequency, I can just use a multiset. Now, how do I use my multiset, guys? Initially, it is 2, 1, 1, because I have not added this element yet. And the frequencies right now are 2, 1, 1. So all the frequencies are put in a multiset. All right. Now, the largest element of the multiset can be just accessed using .rbegin. Right. Star ms.rbegin will give me the maximum frequency in the multiset. Now, while updating, I am updating the frequency of 1 to 2. So what do I do? To add an element, I just erase its current frequency. Then I update its frequency, and then I can just add its frequency here. This is a simple operation. What do I do again? I know which element I want to add. I know its current frequency. It's 1. So it was 211. I removed this frequency from the multiset. Then I updated its frequency in the map to 2, and then I inserted it back again. All right. Now, similarly, if I want to remove a particular element, now let's say it's 212. All right. And I want to make it 211 again. So what do? I know its current frequency. It is 2. So I remove 2 from my multiset. I decrease its frequency by 1. So I make it 1. And then I put 1 in my multiset again. That is more or less all that you need to do to solve this problem. It is a very standard 2 pointers problem. Now, if you know this, all right, I'll just cover if for people who don't know sliding windows. In this range, I can just run a for loop and I can insert everything into my multiset. Okay. Then I know what is the maximum element here. Let's say it's X. Since the size of this window is K, the number of operations I need to do is K minus X. All right. Very simple. Now, I want to slide this window. So I will add this element. Okay. And I will remove this element. And once I do that, I know the multiset for this window. I can store the max. Let's see, the max is Y. So the answer for this range is now again K minus Y. So for all the sliding windows, I can store the answer and then I can answer each query in O of 1. So it's an O of n log n solution, right? Or n log k, because in my multiset, I would have at most k elements. Is this clear for everyone? All right. Now, if this much is indeed clear for everyone, let me show you the code. We can use a map. All right. So I'm having an array and I am having my answer. Initially, I'm doing ARR. I'm taking an input. And as I told, I'm just transforming the array. ARRI is equal to ARRI minus I. Because it will, for for all elements of the same type, it will have the same number. Now I'm having a map and I'm having a multiset. Here is my update function. So if the frequency is being added or subtracted by increment, right? So what am I doing? If ms.find mx is not equal to ms.end, then I'm just erasing it from my multiset. And after that, I'm doing m of x is plus equal to increment. And then I'm doing ms.insert mx. This is basically the update function that I told you, to remove or to increase. While we'll be adding something, we'll put this as +1. And when we'll be removing something, we'll put this as -1. Is this much clear? Is the update function clear? So if the update function is indeed clear, then for all elements in range 0 to k minus 1, I just add it, basically initializing my multiset for the first k element. And my first answer, where my L is 0 and my k is 0 plus k minus 1, I'm storing my answer as k minus star ms dot begin. After that, what do? I remove the I minus kth element. I add the ith element because I'm sliding the window, right? I remove an element, I add an element. And after that, answer of I minus k plus 1. Basically, I want to store the answers. You can store it in any way. The answer for left is equal to I minus k plus 1 is equal to k minus star ms dot r begin. If you do just this much in O of n log k or O of n log n, when k can be maximum n, for every L and R, you just need to print answer of L minus 1 because this is in 1 based indexing and this is in 0 based indexing. A very simple solution. The only hard part about this problem was thinking about this. Is this much clear for every one of y'all guys? And very interesting Div 4 round. We covered 7 problems. I hope they were interesting and they added some value in your lives today. Right? So keep solving more problems. See you guys in the next post contest discussion. Till then, bye bye. Have a great day. Good night. Let me just stop recording.